Greetings, fellow time travelers, and everyone still stuck on Earth. This is another LinuxCollections.com how-to video for your education, information, and entertainment. Let's get rolling. Today we're going to provide an introduction to Bash scripts. Bash, or the born-again shell, is the common command processor for Linux. A script is just a collection of commands that can automate tasks, perform repetitive steps, and can group common commands together, all in an effort to make your life easier. We will cover what is a script, how to make a script, how to run a script, variables, parameters, and conditionals and loops. And this is part of a series for people new to Linux, so be sure to subscribe, click on the bell, and let us know what you'd like to see. We're working with Debian 11.5 with a Cinnamon desktop. To begin, we're going to open a terminal. And once we get in there, we're going to actually make the type just a little bit bigger, and then we'll make it full screen. We want to learn the echo command. This is a command that simply echoes what you tell it to echo or display. So it's like a print command, if you will. So we start with nano, which is a common editor, and we will do my first script. Every bash script starts with the pound exclamation, or the shebang. The hash bang, or pound exclamation, has some interesting aspects. As a leading character, the hash, or pound sign, means a comment line follows. With the exclamation point, or the British bang, as the second character in the file, this becomes a magic number, or a signal to the command processor that this file needs to be handled in a special way. Now this is one of those things where somebody made this up, and that's just the way it is. What is also needed to make this file a script is to indicate the command interpreter. So we list the path and bash interpreter, or the /bin/bash, directly following the exclamation point. Now, as our first script, we will do the hello world, or to print out hello world. We save the file with a Control-X in nano, and then a yes to save it. And then let's ls and review what we've got. Your first instinct may be to simply type the command and see if it runs. Well, in Linux, it just doesn't work that way. Due to security issues, you do need to lead it with a path, and the simplest path is a // or the current directory, and that. Now you'll see that the permission is denied. You may think you need the full path, so actually let's look at pwd to confirm that we are at the /home/dev. We'll try that full path, and unfortunately the permission is still denied. What is needed is a executable attribute. So to look at a file's attributes, you can use ls with a -l or -l option, and that'll list all the file attributes. So when we look at myfirstscript.sh, you'll see that it's got a read-write for the owner, a read for a group, and a read for everyone else. The command to change a file's attributes is the chmod, or change mode, or change file mode. And with the a+x option, you're saying change or add the x, or executable, to all groups, users, and owners. So to do a quick review, you'll see the attributes do not have the execute attribute. Then we run the change mode a+x to add the execute attribute to all groups, users, and owners. And you can also note that the myfirstscript color is changed to green to indicate it's an executable. Now let's clear the screen and run myfirstscript. So we / it, the file down, and we see our hello world. All right, way to go. So now we can do some more fun stuff. We're going to start with variables. Variables are a way to store data in your script. Often you'll see variables all uppercase, but this is not required. When creating a variable in Bash, you just list the word, but when accessing it, you lead with a $ symbol. You can initialize variables a few ways. In our first example, we will execute a command, here the date command. By using the grave accent, or the backtick, to surround the command's output will be saved in the variable. Now that we have the date in a variable called the date, we can echo today is, and then put a $ symbol and the date, and our variable will echo out. So let's save the script and run it. And there you see we've got our hello world, and the today is the date, or the full listing of the date from our variable. So let's continue editing my first script, and we will move on to variables and counting with variables. One of the key things to understand with variables is that the syntax is important, and you must list the name of the variable immediately followed by the equal sign. And so we'll start with count = 1, and we'll echo count, and then let's go ahead and save and run my first script, and you'll see that we have the echo of the number 1. Now we're going to continue, and the first thing you might think is you could do the next count like this, but we'll find when we do that there's an error, and in fact you must not set a variable with the leading $sign symbol. So if we get rid of that and run it again, all of a sudden you get this 1 plus 1. Well, if you look at what count is and then you're adding the plus 1, it's treating it as a string or a text variable. So you need to say let count equals, and you'll see that we now get our counting happening. Now let's say you put a space in there, and if you don't have the equal right, you'll get this operand expected problem. So we got to go and get rid of that space and say let count equals $count plus 1. And now when we run it, we'll get our 1, 2, 3, 4. So now let's move on to parameters. And parameters can be referenced with the $sign and a number. There's one special way to find out the number of parameters that have been passed in, and that's with the $sign number sign, the hash sign. And then by echoing the $sign with the number 1, echo $2, echo $3, we will actually echo out the parameters passed in. So now when we run my first script, you'll see that the number of parameters is 0, and then as we add parameters, test, and next, and then the third parameter, 333. So let's continue and look at conditionals. We'll look at the basic if statement. The syntax for that is a little strange, and there actually is a few different syntaxes in different shells, but this is the most basic, where you have the if word, the double open bracket, your conditional, the close bracket, semicolon, and then the word then. And then you close it off with the fi. So the syntax is somewhat unique to Bash and other shell scripts, so you are going to want some examples and reference material. We have sample Bash scripts at our quick reference page at LinuxCollections.com. I often build off of existing shell scripts because that tends to be easier than remembering the quirkiness of the syntax, and script writing for me is only an occasional task. So let's break down the if-then statement. It starts off like you'd expect with the keyword if, and then you have the open and close double brackets. The conditional comparing the number of parameters to 2 is sensible, and then you just need to remember the semicolon and the ending then keyword. Now you can enclose the statements if the condition is true, and finally, you will close off the entire construct with a closing fi, or a backwards if. There is also the keyword else if needed. This compares numbers, and to work with text, you end up using double quotes in the conditional. So let's go ahead and save that off and run it. Now, if we run it with just one parameter, it says, hey, you need at least 2. When we add 2, then it runs the full script. Now, let's go back and look. Now, I snuck some exits in there. There's a exit 0 that kind of stopped the script right in its tracks below the echoes. And then if there was said need at least 2 parameters, there's an exit 1, and that can then be used as an error code. So typically 0 is success, where any other number can be an error code to indicate what type of error occurred. Let's finish up with the for loop. To start, let's show a directory listing. So let's look at the files in the pictures folder and then simply exit out of the script. So let's save the script and then clear out our parameters and run it. And so you see we have a bunch of JPEG images. So let's get back into our script and put in a for loop. We start with the for keyword, and there are a few approaches to a for loop. Iterate on a list or evaluate an expression. Since we will be renaming a set of files, we will use the variable name of pic, the keyword in, and then the backtick enclosed ls pictures. The body of the loop goes between the keywords do and done. So we'll use the echo of the text pictures and then follow it with the $pic variable. So now let's save that and run the script, and you'll see that below our standard list, we have a line-by-line list with the word pictures followed by the file name. So let's get back in there, and we're now going to add a line that breaks out just the file name itself without the extension of JPEG. Now this is some tricky Bash syntax, and there's no way you would know this. It's not intuitive. So this is where, again, having a reference or looking at samples is so important. So now you see we've got the information we need to actually rename or move the files from a lowercase JPEG to an uppercase JPEG. So let's get back into the script. We will start with the move command mv and then list the existing file. Now, so we can access the base file name, we will actually assign it to a variable name that we name newpic. We can then complete the move command by adding the path pictures / $newpic and then adding the uppercase .jpeg. Now let's run our script. At this point, we have renamed all the files, so let's do a quick ls pictures, and you can see that the files now have an uppercase JPEG, where the listing at the top of the screen shows the lowercase JPEG. Even the color has changed. So that wraps up our introduction to Bash scripts. Today we've explained what is needed for a text file of commands to be handled as an executable script. We've looked at some basic script options such as echo and exit, worked with text and numeric variables, explained how to access command line parameters to send info to your script, and the if conditional and a basic for loop. This should give you everything you need to start experimenting with command line scripts to automate tasks and handle situations that would be tedious otherwise. Thanks for joining us on this journey. This is LinuxCollections.com signing off.